So we've made it to Unit 10, and Unit 10 is a chapter on radicals. Now over the course of the chapter we'll learn how to add, subtract, multiply, and divide radicals, but first we need to know how to simplify them because we are going to make sure that our answers are in simplest radical form. Now that means we need to break down whatever's underneath the square root sign and find out if it contains any perfect squares. One way to do that is to make a factor tree. So I know that 5 goes into 405. And I would multiply 5 times 81 to get 405. Then I can't break down the 5 anymore, but I do have to break down the 81. Now here I have some choices, and if I'm smart about the factors that I pick, then I can end my factor tree early. I don't have to take it all the way down to prime numbers because I know that 81 is 9 times 9. And what I'm really looking for inside my factor tree would be pairs of numbers. And I have a pair of 9s, so I don't need to break them down any further. I can then say that another way to represent 405 would be to be the square root of 5 times 9 squared. Now when I simplify that, I'm looking for pairs of numbers that appear, or perfect squares, and so I'm looking for pairs. I don't have a pair of 5s. That means it has to stay under the square root symbol, but I do have a pair of 9s. So a 9 gets to come out. I have one pair of those 9s. And the 5 will need to stay in. And so when I simplify the square root of 405, I will get 9 square root 5. Okay, so let's look at the second problem. Notice here that we have a negative out in front of the square root symbol. Now that means that we want the negative root. If we don't put the negative there, we give what's called the principal root, and that will always be positive. So the first thing I'm going to do is write down that negative so that I don't forget it. It has to be part of my answer. My answer will be negative. And then I need to simplify the square root of 135. So again, I'm going to do a factor tree. I know that 5 will go into 135, and 5 times 27 is equal to 135. Now 5 can't be broken down, but 27 can. It is 3 times 9. And 9 is 3 times 3. And so looking at the bottom row of my factor tree, I can rewrite 135 as 3 cubed times 5. So I would have the opposite of the square root of 3 cubed times 5. Now again, I'm going to copy down that negative because I know my answer will be negative. I'm looking for pairs of things in here. So I have 3 3s, so that means I have one pair of 3s, and that pair gets to come outside the square root symbol. I have a 3 left without a partner, and a 5. I don't have a pair of 5, so they both have to stay under the square root symbol, and I'm going to multiply them together. So my answer then will be negative 3 square root 15. Let's look at one last problem, and that is the square root of negative 49. So remember, when we take a square root, we're looking for some number times itself. That's going to give us what's underneath. So we're looking for some number times itself that will give us a negative 49. Well, I know to get 49, I take 7 times 7, or I could take negative 7 times negative 7. But in both cases, I would get a positive 49. Since the negative here is underneath the square root symbol, that makes it different than problem 2 where it's outside. This, we're saying what number times itself gives us a negative number. Well, that is undefined over the set of real numbers. So we say that that is undefined. There is not a number that we can square to get a negative 49. We will get a positive 49 in each case. So just to recap then, the negative outside the square root sign means our answer will be negative. A negative inside the square root sign means that we have something that is undefined over the set of real numbers.